All right, so oops, there we go. All right. So as part of the review for the quiz, we're just going to go over one or two homework problems, and then we'll look at the rest of the quiz. So this is basically, this graphing stuff where you have to find the area is basically number 10 on the quiz, okay? So this will be number 10 on the quiz. Something like it, okay? May not be this exact one, but something like it. So you asked about number 23, correct? So read them off to me so I don't have to keep looking at my book. What is it? P is 2, 2. 5, negative 1. 2, negative 4. Negative 1, negative 1. Okay. All right. Go ahead. Yeah. Yeah, it's going to say find the area. I'm going to give you 4 points. I'm going to ask you to find the area of that particular figure. And I'll even give you a little graph thing so you can be kind of precise with it. Oops, there we go. So that would be helpful, wouldn't it? Have a little graph. All right, well, let's plot this. 2, 2. 2, 2 is right there. 5, negative 1. 2, 3, 4, 5, negative 1. 2, negative 4. 1, 2, 3, 4. And negative 1, negative 1. Be right there. All right. So there's your figure. So what do I do with those points? Connect them, yeah. And we're going to see what kind of figure we have. And then we'll find the area of it. That one right there didn't quite land. There we go. That looks a little better. All right, so we got to find the area of this thing. Well, what is this thing? What kind of shape is it? Looks like a square, doesn't it? All right. How do we know for a fact that it's a square? What's that? Okay, you could find the distance. So really a square is a combination of what? Rectangle and a rhombus, okay? So a rhombus means all the sides are equal to each other, and a rectangle means what? All the angles are equal to each other. What's another thing that we learned about a square? Might be a little easier. Because look, if I was to say that all the sides are equal, what am I going to have to do? I'm going to have to do the distance formula 4 times, right? And if I want to see that they're perpendicular, I'd have to find the slopes of all 4 of these and see if they're negative reciprocals. That's like 8 things I'd have to do, isn't it? What's something else I know about a square? We did this in the last chapter. What about the what? The diagonals, right? What do we know about the diagonals of a square? They're equal to each other, okay? Aren't they? So really, if I can just show the diagonals are equal to each other, then I can say it's a what? It's a square. So first of all, I got to decide, is this a square or not? Right? Because they didn't tell me it was a square, did they? And nowhere up here did they say, this is a square. So you got to figure out, first of all, is it a square? Well, do the diagonals bisect each other? Well, let's take a look. Since the diagonals go just vertical and horizontal, really all we got to do is just count, right? Watch. So if I start here, this is what? 1, 2, 3. And then down here, it's what? 1, 2, 3. So that diagonal is being bisected. What about the other one? 1, 2, 3. 1, 2, 3. Sure enough, the diagonals are being bisected. So this must be a what? Must be a square. Okay? Everybody with me on that? So, how do you find the area of a square? How do you find the area? It's just you take one of the sides and you do what to it? Square it. Okay? Right? Base times height, whatever you want. So really, now all we got to do is find one side. Since you know it's a square now, do you really even have to find the other side? Not really. So let's just find the one side, right? So how do we find that? Use the what? Distance formula. That's what I would do, wouldn't you? Let me see what the book does. They don't really say how they found the sides. They just said the side is whatever it is. But let's just do it. All right. This is how I would do it. So what's this? I should have put my points in here. What is this? P. And this one's Q. This one's R and S. All right. So I don't care which one we find. Let's just do PS. Let's find that one right there, okay? Let's do the ones that are next to each other, PQ, all right? Since they're right next to each other. So what do? Find the distance. I think this is the easiest way to do it. I don't know. There could be an easier way. If you did it in an easier way, just let me know. So what do we do here? Subtract the what? Subtract the x's. Doesn't matter what order we subtract them in. I'm just going to go 5 minus 2. Is that all right? Then I'm going to go what? 2 minus negative 1. Why did I do that? Just keep it positive. Either way, it doesn't matter what order you subtract them in. You're still going to get the same thing anyway. So what's this? 5 minus 2, which is 3. 3 squared is 9. Yes? Plus, what's this? It's also 3. 3 squared is... Did I do that right? Oh, I see what they did. Oh, I see what they did. Oh, man. I'm so dumb. Thank you. Look, I did that whole diagonal thing, right? So watch. You could have done it that way, okay? And just, this is a lot easier. I wasn't even thinking. So they're bisected, but they're also what to each other, these diagonals? They're equal to each other. Agreed? So really, all I got to do is just find, well, let's say this. That really didn't make any difference. How do I find the area of a rectangle? Okay, I go base times height. I could do that, right? So I could find one side, multiply it by the other, and I got the area. Okay, this is also a parallelogram. Is that right? No, what is it? It's also a rhombus, isn't it? How do I find the area of a rhombus? Since I already have the diagonals, and it's very easy, all I got to do, since I got it on graph paper, is just count. Once I got the diagonals, then remember, a square is a rhombus, right? We talked about that earlier. So what's the area of a rhombus? It's got diagonal in it, doesn't it? You got to know it. What is it? It's half times what? D1, D2, correct? All right. So look, I can just count and find the diagonals, can't I? So really, I don't have to do any complicated math at all. I don't even have to do the distance formula. All I got to do is use my graph, since I graphed it, and just count how long the diagonal is. What is it? 1, 2, 3, 4, 5, 6. What's the other diagonal? Same thing. You with me? Yep. And then, what's this? Half of 6 times 6? 36. What's half of 36? 18, and there it is. We don't know what the units are, so what do they write? Units. They just write u squared. If you want to write the word unit out, it's fine, and go like that, however you want to do it. And that's the area. So it actually worked out kind of nice. I mean, you could find the area of this a lot longer of a way. Like I started with that distance formula. Find the distance of this, find the distance of this. And then multiply them together, right? Don't take half because it is a square. But I think that's the easiest way to do it right there. I think that's the easiest way. It's not the only way. I think it's the easiest way. And it was kind of nice that they made these vertical and horizontal, wasn't it? So really all you had to do was count. You really didn't have to do distance formula at all. So yeah, that's not too bad. You want to do another one like that? Was there one that was a little different? What about 25? 25 looks a lot more complicated. I'll tell you what, let me see something. Yeah, let's do 25. No, let's not do that. Okay. 24. it's way more complicated than you're going to see on the quiz. Just don't want to waste our time. I mean, it's not a waste of time. If all we were doing today was just going over the homework, yeah, we'd do it. But we're also trying to review for the quiz. And the one on the quiz is not going to be near as complicated as 25. 25 is a little more complicated. But 22, 3, and 4, you could see one of those on the quiz. Huge hint, okay? All right. I'm not telling you which one, but one of those you could see on the quiz. So what did you say you wanted to do, 24? Make this just a little bit bigger. There we go. All right. Who's reading them off to me? So what is it? A, B, C, and D? Oh, I'm looking wrong one. Which one are we doing? 24. Oh, K. All right, there we go. KLMN. So what's K? I can't hear you. Don't whisper. 0, 0. Is it my hearing that's just going bad, or you just guys aren't talking very loud? Could be a combination of both. L is 3, 0. M is 5, 5. And N is 0, 3. Did I get that right? Okay. All right, so let's mark it on this. 0, 0. 3, and I'll put the letters in here. That's K. And then L is 3, 0. 1, 2, 3. That's L. And then 5, 5. That's 3, 4, 5. 1, 2, 3, 4, 5 right here. That's M. And then N is 0, 3. 0, 1, 2, 3. There we go. So we're going to connect them. And that's what it should look like. Did you draw something like that when you did the homework? You didn't? All right, so what are we trying to do here? This is N. Trying to find the area of this thing. Well, first of all, what does it kind of look like? Looks like a kite, doesn't it? All right, let's verify that it's really a kite. How do I know it's a kite? Well, these two should be equal to each other, agreed? And they're easy to find, right? So what do I do? 1, 2, 3, right? So that length is 3. This length is 1, 2, 3 as well. All right, what about this? Well, let's take a look. Watch what we can do. Without actually doing the whole math, how did we get that length? We went up 2 and we went over what? 1, 2, 3, 4, 5. Do you see that? All right, so we went up from endpoint to endpoint. I know that's finding the slope, but really, if we go the same up and down as we go across, we're going to have the same lengths. Would you agree? So this one length is 2. This length right here is 5. Let's find this one right here. What's this length? That's 2. What's that length? That's 5. So you got a 2 and a 5. You got a 2 and a 5. So the hypotenuse has got to be the same, right? That kind of leads us into Pythagorean theorem, which we're going to talk about after the quiz, after we take the quiz, okay? So yeah, so they are the same. So this and this are the same. I don't really have the numbers, but I don't really need them, because what I'm going to do is it's a kite, so what's the area of a kite? Same thing as the area of a what? A rhombus. Okay, so what is it? Half what? D1, D2. So what do we need to write here? We need to find the diagonals, correct? Let me see if that's the way they do it. Yes, it is. All right, so you got to find that length. If I can find that length, and I can find that length right there, the two yellow ones, right, then I multiply them together, take half of it, and that's my area. Everybody with me? All right, so now that's what we're going to do. So now we do have to do a little work with this. So let's find this longer one right here from K to M. They call it the axis of symmetry, all right? So we're going to find that. So K and M, these two right there. So let's put it in the distance formula. Doesn't take too long if you know what you're doing. Subtract, we can just do that in our head, right? 5 minus 0 is what? 5. Then another 5 minus 0 is 5. Agreed? 5 squared is 25. 5 squared is 25. Take the square root. What is that? The square root of what? 50. All right. We're going to simplify that, though. Let's simplify it. You know how to do simplify the square root of 50? I would turn it into 25 times 2. Why would I use that, not 5 times 10? What's special about that 25? Why did I pick that to be 25? Okay, I can barely hear you, but I think I heard what you said. You guys are just mumbling. Did you know that? Maybe I'm just getting old and I can't hear very well, but it just seems like you're mumbling and I can't hear. I got this fan blowing right next to my computer, so that kind of, then I got the noise in the other room. So anyway, did you say because you can take the square root of 25? Okay, good, because that's right. So what is this? It's the square root of 25 times the square root of 2. What's the square root of 25? It's 5. But then you still got to take the square root of 2, so you leave it like that. Remember us doing that? Yeah. That's something you should have learned in Algebra 1. Not everybody does. But I did talk about that at some point in this class. All right? So that's what this is simplified. That's the distance. That's this long distance right there. I'm not going to circle it. It's not my answer. I'm just going to put it in a box, keep it for safekeeping. We're going to come back to it. Everybody with me? All right. Excuse me. Let's do the other distance. It's that short one right here from N to L. Oops. Got to pop this back up here so I see my points. N and L. So it's this one, or LN, however you want to see it. So let's set up our little distance formula thing again. All right. And so what? 3 minus 0. You can do that in your head, can't you? What's that? 3. What's this one? It's another 3 minus 0, which is 3. Agreed? Square root. 3 squared is 9 plus 9. All right. You could look at it a couple different ways, but we're going to approach it the same way as we did the other one. What is that? Square root of 18. But then let's break it down. It's 9. Well, let's not use 6 times 3 because I can't take the square root of 6 and I can't take the square root of 3. But what equals 18? What times what equals 18 wherein I can take the square root of one of those? 9 times 2, right? So I'm going to pick 9 times 2. Now, you could have gone 6 times 3, but then you'd have to do an extra step. I'm not going to do that. So what's the square root of 9? It's 3. What's the square root of 2? It's just the square root of 2. It's not a 2. It's the square root of 2. All right? I'll keep that for safekeeping. And I'm just about ready to use it right now anyway. So what are these? These are my two diagonals, correct? So what are we trying to find? The area. What's the area? It's 1/2 d1 d2, correct? So we got them both. So we got our 1/2. What's our d1? It's 5 times the square root of 2. What's our d2? 3 times the square root of 2. Correct? All right. Let's do a little bit. So you got to know a little bit about square roots to be able to get this completely right. It's not too hard. Let's keep the 1/2 right there. We'll deal with that later. Let's take the 5, put it here. Let's take the 3 and put it there. You okay with that? And then what I'm going to do is put the square root of 2 here and the square root of 2 here. Why did I do that? Just so I get my regular numbers together and I get my square root numbers together. Okay? What's the square root of 2 times square root of 2? What do I do when I take a number and I multiply it by itself? What am I doing to it? It is 2. But why? Listen to my train of thought. What do you do when you take a number? Let's take any number, 7. If I multiply it by itself, what am I doing to it? I'm taking that 7, I'm doing what to it? No, I'm not doubling it. If I doubled that, that'd be 14. 7 times 7 is not 14. What am I doing? I'm taking it to the second power. I'm squaring it. Okay, Denise, you getting all this? Okay, I'm squaring it. You understand? So what am I doing here? I'm multiplying something by itself. So I'm taking that number, and what am I doing to it? I am squaring it. What happens when you take a square and a square root? They cancel out. So what is that? It's just a 2. It's not a 0. These cancel out. What am I left with? I'm left with that number right there. Okay? So what is the square root of 2 times the square root of 2? It's right here in front of you. What is it? It's 2. Good. So let's write it again. 1/2 times 5 times 3 times what? 2. Now let's do this math. First of all, I'm not going to go half of 5. I'm not going to go half of 3. I'm not going to go half of 15. What am I going to do? Half of 2. What's half of 2? It's 1. So really, those go away, don't they? All right? It becomes a 1, but in effect, we don't really need it. So now, what's my answer? It's 15. So the area equals 15. Okay, units, what? Squared. I know you kind of got bogged down in the square root stuff, and we're not really teaching square root stuff in here, but I've taught you this before, all right? And it's definitely something you're going to have to know when you get to Algebra 2. We're going to do a ton of that. Did you do a lot of that square root stuff in Algebra 1? No? You should have. All right. Easy for me to say, right? Because I didn't teach it. I didn't know how fast you went. I didn't know where the square root is in your book and all that kind of stuff. So there we go. What's that? This? Because it's part of Pythagorean theorem, which we're technically going to teach tomorrow. Well, not tomorrow. Well, whenever. Maybe tomorrow. Maybe I'll start it tomorrow after you take the quiz. So that, like, for what we're doing. Because it's Pythagorean theorem. Remember a squared or c squared equals a squared plus b squared? Basically what we did is we solved for c. All right? And so how do you get rid of something? You do the opposite. What's the opposite of squaring something? Square rooting it. So I square root this side. So that's why that square root's there. Okay? But again, they taught you the distance formula before they officially taught you Pythagorean theorem, which is kind of weird. They should have taught you Pythagorean theorem first before they even talked about the distance formula. Oh, no. I mean, to do the distance formula, you technically absolutely have to have the square root. You didn't get it right. No, you didn't. You made a mistake somewhere else then. Okay? Because, no. 2 wrongs, what do they say? 2 wrongs don't what? Make a right. Okay? 3 lefts do? Okay. There's 1 left. There's 2 lefts. There's 3 lefts. That just gets you back to where you started. That's not a right. That's going to, yeah, but it just gets you. You didn't actually turn right, though, from where you started, though. Okay. Not for, you're going to the right, but you basically just end up where you started. You're still going to the right. But to go to the right, like if you start here, okay, I can see what you meant. Going to the right. Anyway, still. You got to do things right. And you have to have a square root there for the distance formula. Absolutely have to have it. All right, enough of that. Let's go through the test. That was number 10. All right, all that we did was basically just preparing you for number 10. All right, I will give you graph paper, a little graph thing on the quiz. And, plot the points just like we did. Look at it, try to figure out what kind of figure it is, and then find the area of it. And you should know how to find the area. So after we do 1 through 9, I think we'll have all the area stuff covered, the area of every one of these figures. So, all right, so what if I give you, again, I'm not giving you on a lot of these, I'm not going to get real specific and put numbers in. I'm just going to show you how to do it. So this is number 1. So I'm going to ask you to find the area of this, and here's some stuff that I'm going to give you. All right, I'm going to give you basically everything. I'm going to give you all 3 sides, and I'm giving you that dotted line distance. Okay, I'm giving you all of those. Everybody with me on that? All right, so I'm going to ask you to find the area of it. So how do you find the area of it? Well, it's the area of a triangle. How do you find the area of a triangle? It's the base times the what? Height divided by 2. Would you agree? All right, so which one is the base here? Is it this left one, the right one, the bottom one, the dotted one? Which one is the base? The bottom one. This is the base. So the base goes from here all the way to here. Everybody got that? Okay, so, and I told you, they give you all three of these sides. I'm not putting numbers in. You can do that yourself, okay? So I'm giving you the base. And which one's the height? This is the key. Which one is the height? The dotted line, that's right. Because it's perpendicular, right? The base and the height have to be perpendicular. So do not consider this to be the height. That's wrong. Don't consider that one to be the height. That's wrong, okay? If this is your base, then this dotted line is your height, all right? So you multiply the two numbers together, divide by 2, boom, you got the area of that whole entire triangle. We got it? Then you're going to have one of these. You did quite a few of these. I'm just going to make one up. Like you had this, and you might have had something like this. Not lining these up very well, am I? Got that one. Remember this stuff? And let's make this one match up. Remember this? And I asked you to find the area. So what would you do to this? I'd break it up into a couple rectangles, wouldn't you? Now, on the one on the quiz, it's just a tad more complicated than this. There's a little bit extra to it. But on this one, what would you do? I mean, they give you a whole bunch of stuff, right? They give you this length, they give you this length, they give you this one, and so on. Okay, they give you a whole bunch of stuff. But basically what you're doing is you're going to break it up into two rectangles. There's number 1 rectangle, there's number 2 rectangle. You with me? If that's the base and that's the height, multiply the base and the height. Do we divide by 2 here? No. All right, because it's not a triangle. So this is base, this is height, and then you've got this area. Then, now what do? Then you got another base. You got this little base right here, don't you? And you got this little height right here. Multiply those together, and you've got that.
So you're going to give us all these numbers?
I'll give you enough numbers for you to, I may not give you every single one, but you should know. Like, for instance, if I told you the whole entire bottom was, let's say, 10, and I told you this was 6, and I didn't tell you this one, you should be able to figure out what this one is. What's that from here to here? It's 4. Everybody see that? All right, because look, that goes over 6, so right here is 6. Agreed? And then if this whole thing is 10, then this part right here has got to be 4, and that run up there has got to be 4. So that kind of stuff. So there might be a couple that I leave out, but you should be able to figure out what those lengths are. All right? You could have, I'm going to really make a mess of this. I'll do it in a different color. You could have made it like this, couldn't you? And then you've got this rectangle, and then you've got this rectangle. You could have done it that way too if you wanted to. What do you do once you find those two rectangles though? Just add them up, right? Okay, so you're finding the area of the first rectangle plus the area of the second rectangle, and that's the total area. Agreed? Yeah, that's pretty easy. All right, so I give you the pictures and everything for that, so you should be good to go. So what about number 3? 3, 4, 5. 3, 4, and 5. 3, 4, and 5 are kind of similar. I don't give you any pictures, but I tell you what the figure is. All right, and then I give you some information, and you just have to find the area of it. And it's straight up finding the area. It's not one of those, remember those ones yesterday where they give you the area and you had to find the base or the height or the diagonal or something like that? This one, 3, 4, and 5, all you have to do is find the area. And I tell you what figures. So let's review briefly. What's the area of, we already did rectangle. Well, we did a bunch of them already. What's the area of a rectangle? It's just the base times the height, correct? What's the area of a triangle? It's 1/2 times the base times the height, or you could write it, what? Just base times height, what? Divided by 2, right? What about a parallelogram? Area of a, I'll put P for parallelogram. What is that? That's also just the base times the height, isn't it? Okay? You with me on that? But remember, the height and the base have to be perpendicular to each other. All right? But they're going to tell you. They'll tell you the base. They'll tell you the height. Now all you got to do is just multiply them together. Make sure you put the units, though. All right? Make sure you write the units. I'm not going to tell you the formulas. You have to know the formulas. That's why I'm writing them down right here. Okay? You have to tell me the units. So if it's in inches, if it's 3 inches times 5 inches, and what's the area? It's what? Let's say it's a rectangle. 3 inches by 5 inches. What is it? It's 15. Is it just 15 and you circle it like that? Yeah. Guess what I'm going to do if you just do that? I'm going to mark it wrong. Yep. So if it's in inches, what's your area? Inches what? Squared. So that's how you need to write it. I hate to do it, but I've been telling you since we started this stuff that you have to write the units. Okay? I'm going to stick to my guns. Everybody hear me? Now, you know on a quiz anyway, even if you get it wrong, how many? 50. I still give you 1 point out of the 2, don't I? All right, I only take 1 point off. I should take 2 points off because you got the whole thing wrong. But I still only take off half. So I still give you a little bit of a benefit. So I help you out. You write the units in, okay? Get both points. I would hate to mark it wrong because you didn't put the units, but I will. All right. Then 6, 7, and 8. I give you a picture, 6, 7, and 8. I give you pictures and I ask you to find the area. All right, so I give you pictures this time. But I'm still asking you to find the area. You're not going to have to find the base. You're not going to have to find the height or anything like that. You actually find the area. So what are some other areas we haven't talked about? What about the rhombus? What's the area of a rhombus? Do you remember that? You could do it a couple ways. What about the diagonals? Using diagonals. What's the area when you use diagonals? Yeah, 1/2 D1, D2. All right? Okay, you got that? What about a trapezoid? We haven't talked about that yet. What's the area of a trapezoid? Remember, trapezoid doesn't have one base. How many does it have? It's got 2. T, right? Triangle starts with T. Trapezoid starts with T. So it's kind of similar to a triangle. So what is it? 1/2. That's right. You add the 2 bases together. Since it has 2 bases, you add the 2 bases together and then times the height. Excuse me. Isn't this very similar to the area of a triangle? Yeah, 1/2 the base times the height. Except the trapezoid doesn't have 1 base. It's got what? 2 of them. What do you do with those 2? You add them up. Good? And then one more we haven't talked about. Well, we did when we did one of those examples or one of those problems from the homework. The kite. So what's the area of a kite? It's already up there. It's 1/2 what? That's right, D1, D2. All right? So 6 and 8, they have pictures. All right? They don't just tell you the bases and the heights and all that. Okay? They give you a picture. You got to figure out which one's the base, which one's the height, which one's the diagonal, all that kind of stuff. All right? Then you got one more because we already did number 10, right? Reviewed number 10. So number 9 is one of those where they tell you the area and you got to find one of the other things. Okay? So I'll put given. Given is the area. So they tell you the area. All right? So let's just make one up. Let's do an easy one. Let's do triangle. All right? Again, I'm just making this up. The one on the test is not a triangle. All right? So the area of a triangle is base times height divided by 2, right? So they tell you, they give you the area. So, no, would you say 50? All right, 50 is good. Let's say, what unit? Centimeters. Let's go centimeters, okay? What else do you think they tell you? So they tell you the area is 50 centimeters squared. Actually, when we do the math, might be better if we just left out the units and then just put them at the end, okay? I don't know. Give me either a base or height. Doesn't make any difference. Height is, just give me an easy number, 10. Good. So it's 10 centimeters. So watch what we do. Put the 50 in for the A, right? The base, it's just base, because we don't know what it is, and we're going to find the base, right? Again, I'm just making this problem up on the fly. Find b. All right. So what do? Base times height. What is the height? It's 10. That's supposed to be a b. It looks kind of weird. It looks like a 6, but it's a b. And then over what? 2. Correct? You could do this a couple ways. Here's how I would do it. I got a 10 on the top, 2 on the bottom. What does that become? It just becomes a 5. So really it's b times 5 or what? 5b. Agreed? Now divide both sides by 5. B is 10. But how are we going to write it? The base is 10 what? Centimeters. It's not squared. Remember, the height and the base are both just straight up centimeters. Only the area is squared. Okay? Only the area is squared. If you don't write centimeters here, yes, it's wrong. If you write centimeters squared, that's wrong. Okay? Because it's not 10 centimeters squared. It's what? It's 10 centimeters. Okay? Math is about getting things right. Okay? It's not a matter of how you feel. It's not a matter of what your view is on something. We all have to be in agreement. Okay? And so that's the thing about math. That's the thing I like about math. All right? That we don't have to just, especially being a math teacher. I would hate to be an English teacher and grade papers and did I like how they write? That is so subjective. When you agree? This is completely objective. You know the difference? Subjective means you just kind of, it's your opinion, your view on it, your feelings on it. But objectivity means it doesn't matter who's grading it. 10 centimeters is the only right answer. Okay? You with me on that? Okay. All right. I think that's good. What's that? Well, if I said millimeters squared, then this would have to be in millimeters. But if you put 100 millimeters, I still don't want you to write that because everything I gave you was in centimeters. So put 10 centimeters, okay? Even though 100 millimeters would be correct, don't write it like that. Don't even test me on it, okay? I don't think so. It doesn't look like any, I'm looking at it, meters, millimeters. Yeah, there's none in here where you have to convert. There's none where they give you inches and feet. You got to decide which one you want to change it to, okay? Everything's either just inches, feet, centimeters, meters, whatever they give it to you. Everybody ready for it? All right. So just plan on not taking the whole period to do the quiz, okay? I'll probably give you maybe 30 minutes. And then and that should be plenty of time. It's 3 minutes a problem, okay? Some of these will take you seconds to do, all right? And that gives you more than 3 minutes a problem for the other ones. Would you agree? Yes. So be ready for it. Be prepared for it. And it should be pretty easy if you paid attention and if you know what you're doing, I guess. I guess it's always easy if you know what you're doing, isn't it? All right. That's it.